Hello, trigonometry geometry friends. I said that last time. I'm saying it again because it's so fun to say. Today, we are going to do a video on the law of sines. And up until this point, I've been saying that you can only use SOHCAHTOA trig when you have a right triangle. And that is true. You can only use the ratios of opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent when you have a right triangle. But in fact, you can use trigonometry, sine, cosine, and tangent in other ways too. And that's what today is all about. So this opening exercise says, all right, given triangle DEF that's right here, we got the 22, the 91, the 16.55, the 6.74, find DE to the nearest hundredth. Well, one option is I could use the Pythagorean theorem. I have two sides. I want to find the third side. Yeah, I can't do Pythagorean theorem because that's not a right triangle. That's 91 degrees, not 90. So the Pythagorean theorem won't work. Another option is we use SOHCAHTOA. What? No, I can't use SOHCAHTOA. I don't have a 90-degree angle, so that won't work either. So can we answer this question? No, not so much. We cannot right now. Okay? There are things we can do, and that's what I'm going to talk about. All right. Why can't we use trig or basic Pythagorean theorem to find DE? Because this isn't a right triangle. All right. But I still want to find that side though. And if there's one thing mathematicians don't like people telling you is, hey, you can't do that. And we like to go, well, yes, I can. And then we figure it out. And us figuring it out led to the law of sines. Okay. The law of sines says if you have any triangle, you can set up an extended proportion that says that the sine of A over side A, pardon me, the sine of A over side A equals sine B over B equals sine C over C. I want you to Let's try that again. I want you to write this. The sine of an angle over its opposite side is going to equal the sine of another angle over its opposite side if you're within one triangle. Okay? We use the law of sines by saying take any triangle, the sine of an angle over its opposite side equals the sine of a different angle over its opposite side. Let's do that for the triangle up above. Let me show you how the law of sines works. So I come over here, I say, what am I trying to find? I'm trying to find this. Well, that x is across from 91. So I would say sine 91 over x equals. Then I want to pick the sine of another angle over its opposite side. Well, let's see. The only other angle I got is 22. And 22 is across from 6.74. So I'm going to write sine 22 over 6.74. It's that simple. The sine of an angle over its opposite side equals the sine of another angle over its opposite side. Okay, well, I want to solve for x, and I have two fractions facing each other, so I am going to do cross multiplication, the cross product property. X sine 22 equals sine 91 times 6.74. I'm trying to solve for x. Right now, x is being multiplied by sine 22. So I'm going to undo that multiplication by dividing. And then I'm just going to throw that entire thing into the calculator. Sine 91 times 6.74. Okay, let me move my face out of the way. Sine 91. Okay, then get out of the parentheses. Sine 91, close the parenthesis, times 6.74. And then I'm supposed to be dividing by the sine of 22. Enter. And I get 17.9895. And it says to the nearest hundredth, 17.9895. Yeah. And to the nearest hundredth, that would be 17.99. And there you go. Now, I hate giving you a rule without telling you where it comes from, so I'm going to take the next 2 minutes to explain where the law of signs come from. You do not ever need to repeat this back to me, but I don't want it to be this magical formula that showed up out of thin air, all right? So, why does the law of signs work? So, let me show you where the law of signs comes from. So if I have a triangle right here that's not a right triangle, and I say this is like 42 degrees and that's like 95 degrees, and I know this is 18, and let's say I want to find, I don't know, x over here, we can say, well, I can't use trigonometry because I don't have a right angle. Well, the mathematician would say, well, tell you what, I'm going to make one because I want to. And so we would just drop an altitude down there and say, all right, well, now that I have that nice altitude there, I have two 90-degree angles, in fact. And if I know that this is 42 and that's 95, 95 plus 42 is 137. And so this, so that it adds to 180, would have to be 43. Cool. Well, I still can't find x yet, but you know what I can do? I can find h. And I can say the sine of 43 equals h over 18 because the sine of 43 would be opposite divided by hypotenuse. Okay, fine. And then I can also say, you know what? I can use this 42 with h and say that the sine of 42 equals h over x. Okay, I'm okay right now. Those both have an h in them, so you know what? I'm going to solve them both for h. So h equals x times sine 42. H equals 18 times sine 43. And that means x sine 42 equals 18 sine 43. And then if I do some rearranging here, I'm going to divide both sides by x. And so I have sine 42 equals 18 sine 43 over x. And then I'm going to divide both sides by 18. And then I have sine 42 over 18 equals sine 43 over x. Now, look at what I've got. I have sine 42 over 18. 42 is opposite 18. Then I got sine 43 ends up over x. There's the 43, there's an x. So the law of sines actually did come from SOHCAHTOA trig, and it came from dropping a right angle in there and then basically using that h twice. Now, if what I just did made your brain explode, don't worry about it. Just know how to use the law of sines. But I wanted you to see that technically the law of sines does come from SOHCAHTOA trig. It's just the SOHCAHTOA trig kind of disappears along the way. Okay, Mrs. Bibber, stop pontificating. Just get to the point. Here's the point. The law of sines can be used for any triangle. Right, acute, obtuse, doesn't matter. You draw a triangle, the sine of an angle over its opposite side equals the sine of another angle over its opposite side. It's as simple as that. So in triangle ABC, I don't see an ABC, so I'm going to make one. Angle A is 33. Then it says lowercase a is 12. That has to go across from uppercase a. Okay, so when you see a side labeled as a lowercase letter, if capital A is here, lowercase a is across from it. Angle B is 43. What is the length of side B? Okay, so I want this. I'm going to use the law of sines. The sine of an angle over its opposite side equals the sine of another angle over its opposite side. 33 and 12 are across from each other. 43 and B are across from each other. B times the sine of 33 equals 12 times the sine of 43. I got to solve for B, so I'm going to divide. And I get B equals 12 sine 43 divided by sine 33. 12 sine 43 divided by sine 33. 15. What's it say it around to? Nearest hundredth, 15.03. That's the law of sines, folks. Let's do it again. In triangle XYZ, okay, X, Y, Z. Angle Y is 87. Side Y is 14. Side Z is 12. Find the measure of angle Z. Instead of calling that X, I should probably call it Z. Find the measure of angle Z to the nearest tenth. Okay. The sine of an angle over its opposite side equals the sine of another angle over its opposite side. All right. I'm going to solve. So cross multiply. 12 sine 87 equals 14 sine Z. Okay. Trying to solve for Z right now. So I need to get Z alone. I'm taking the sine of Z and I'm multiplying by 14. So I'm going to divide by 14 first. And then I get sine Z equals all this. So let me type that into the calculator. 12 sine 87 over 14. 12 sine 87 divided by 14. Oops, I didn't hit 14. 12 sine 87 divided by 14. There we go. Is 0.855968. I still need to get Z alone, though, and Z is attached to a sine. Oh, if I want sine to go away, we use that inverse sine thing. So I'm going to take the inverse sine of both sides. So I get Z equals inverse sine of 0.855. So inverse sine of the answer is 58.86. Find the nearest tenth, so 58.9 degrees. All right. Last one. I think it's the last one. Yep, last one. Fire breaks out. 80 feet from the ranger's tower. Ha da 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 da. So if I look at this, a fire breaks out 80 feet away from the ranger's tower. The ranger needs to run to the water tower to open the tower spout. How far is the run? Okay, so I want to know this. Here's the problem. I don't know the angle across from X, and we keep doing all these things based on the angle across from it. That's okay. I know the two other angles. So if this is 46 and 28, 46 plus 28 is 74, which means this has to be 106 degrees because the three angles need to add to 180. So if you're ever missing an angle, you want to subtract from 180 to find it. So the sine of an angle over its opposite side equals the sine of another angle over its opposite side. Cross multiply. Solve for x, so divide. $80 sine 106 divided by sine 28. 80 sine 106 divided by sine 28. 163.8, and it says to the nearest foot, so 164 feet. That's the law of sines, my friends. For any triangle, right acute, obtuse, it doesn't matter. The sine of an angle over its opposite side equals the sine of another angle over its opposite side, and then you use the cross product property to solve. I hope that made some sense. If it didn't, let me know, and we'll talk again soon. Have a great day.